Welcome to this M2 walkthrough video of the May 2023 paper. Okay, first question is impulse. So impulse equals mv minus mu, or the change in momentum. So that is 0.3 multiplied by 7i plus 7j minus 0.3 multiplied by 5i. Or we could write that as 0.3 multiplied by 7i plus 7j minus 5i. So 0.3 multiplied by 2i plus 7j, which is 0.6i plus 2.1j. Okay, so that's the impulse. Now we need to find the magnitude. So the magnitude of that is 0.6 squared plus 2.1 squared. It's the size of it, like a vector. When you've got horizontal and vertical vectors, that diagonal that joins them is just basically Pythagoras. So that is 4.77. The square root of, or working it all out in one go, we get 3 root 53 over 10, or that is 2.18 Newton seconds, and that's 3 significant figures. Now part B, find the angle between the direction of I and the direction of motion of P immediately before receiving the impulse. So immediately before, it was travelling at 5i, so that's the way it was travelling before. And then the impulse is 0.6i, 2.1j, so it's, it's going up this way somewhere, and that is I. So 0.6, 2.1, and call that theta. So tan theta is opposite over adjacent. Theta equals 74.1 degrees to 1 decimal place. Okay, and that's all it is. Okay, the little diagram, obviously, if you can draw a little diagram for these mechanics questions, it really helps visualize what's going on and find exactly what needs to be found. Okay, so in this question we've got the position vector of this P when t equals 0, and we've got the velocity here. So what we need to do is we need to integrate the velocity, because that distance s is the integration of velocity with respect to time. Okay, so that's where we're going to start. Then we'll be able to find how far it goes within the 2 seconds, and then compared to this, then we'll find its actual position. So we're integrating 4t squared minus 5t I plus minus 10t minus 12j dt. So that is 4t cubed over 3 minus 5t squared over 2 I plus minus 10t squared over 2 minus 12t j plus c. Now we know this, so we can substitute that in when t equals 0, r equals 2ij. Okay, so you know my s is my r, so 2i plus 6j equals 4/3 times 2 squared. No, sorry, 0, isn't it? 0 squared. Oh. They've all got t in it, isn't it? 0 minus 0, I plus 0 minus 0, j plus c. So c equals 2i plus 6j. So my s, or r, is 4t cubed over 3 minus 5t squared over 2 plus 2i, and then it's minus 5t squared minus 12t plus 6j. Now for when t equals 2, I will start calling this r, as you know it is in the question, find r when t equals 2, so r equals 4/3 times 2 cubed minus 5 times 2 squared over 2 plus 2i, and then it's minus 5 times 2 squared minus 12 times 2 plus 6j. So carry on up here, r equals, just put this in my calculator, and I get 8/3i minus 38j. Right, let's get on now to part B. So what we've got for this part B is we've got 4t squared minus 5ti plus minus 10t minus 12j. And what we need to do is kind of create an equation, and we've got this I minus 2j. So this is going in I minus 2j. So what we've got to do is kind of make these equal. So make the I part and the j part equal to each other. So for example, 4t squared minus 5t, using the capital T here for when t equals t, and then minus 10t minus 12. Now, so that I can put an equal sign in front of them, I've got to do a bit of multiplying. So if I multiply the left by minus 2, yeah, so if I multiplied this I by minus 2, it would be minus 2i minus 2j. So if I multiply this left by minus 2, it will equal this. Okay, so that's what I'm trying to do here. And then it's just a case of expanding and solving. So minus 8t squared plus 10t equals minus 10t minus 12. So 8t squared minus 20t minus 12. 4 goes into each of them, so I'll divide by 4 first. So 2t squared minus 5t minus 3. Now factorize. If it will factorize, you can use the formula, and you can use your calculator as long as you show all you're working out. So, you know, you could kind of work backwards from your calculator, couldn't you? 1 and 3. Minus and plus. So 2t squared minus 6t plus 1t minus 3. So that gives me 2t plus 1 equals 0, or t minus 3 equals 0. So t equals 3, t equals minus a half. Minus a half is obviously a no-no because we can't have negative time. Can't go backwards in time. So t equals 3. So part C now, find the exact magnitude of the acceleration. So acceleration is dv by dt. So that is differentiating this. So that's 8t minus 5i plus minus 10j when t equals 2.5, a equals, so 8 times 2.5 minus 5, I minus 10j, so 8 times 2.5 minus 5 is 15i minus 10j. Now we need to find the magnitude of that, so that's just Pythagoras. 15 squared plus minus 10 squared. So 15 squared is 225, minus 10 squared is 100, so it's 325. Square root of 325 is 5 root 13, or 18.03 meters per second squared. That's the 2 decimal places. Oh, it's the exact value. Forget that bottom bit. Meters per second squared. So it's 5 root 13. Okay, here we have a centre of mass question. Now, first of all, let's find the mass of the whole shape. And it is 6x base, 9y of the height. So triangle ABC is half times 6x times 9y. So 27xy. So that is the area of triangle ABC. Next, now we've got to find D. D is the centre of mass of F, this shape, from PQ. So what I'm going to do is I'm going to make PQ my x-axis, and then through A, so through A my y-axis. So I've got my x-axis, just make that a little bit longer, and my y-axis. Now triangle APQ is similar to triangle ABC. Okay, they're similar triangles. It's in the ratio of, well, this is in the ratio of 2 to 1, and that's 2 to 1 there, which when you look at the lengths, that's in the ratio of 2 to 3. Okay, so that's the ratio there. So like the ratio of AP to AC is 2 to 3. And because they're similar, that ratio will apply to every side within the triangle. Now, we know that this total length here is 9y. This is in the ratio of 2 to 3. So 3 parts is 9y. So 1 part is 3y. So 2 parts is 6y. So this distance here is 6y and 3y in terms of like this distance and this distance. So if you think about it, this is 9y to 6y when we're looking at, call this the origin O. So this would be, OA to wherever this is down the bottom here. I can't think of what letter to call it. But yeah, that's, if I call that D, it'd be to AD, the full length. Okay, so that's what we got so far. Now, from that, we can find the coordinates of each, well, not quite each of these yet, but certainly the coordinates of this one. We'll work out the x coordinates of these ones next. So first of all, I'll just do the coordinates. So this B is going to be at 3x minus 3y. C is minus 3x minus 3y. And A is at 0, 6y. Now, the ratio 2 to 3 applies to everything. So, OQ to what is effectively like OB, or DB in this case, I've put as in that. It's 2 to 3. So this is 3x, so this one is 2x. So Q is 2x, 0, and P is minus 2x, 0. So now I've got the coordinates of my ABC and my P and Q. Now, centre of mass of triangle ABC. So that is my x terms. So 0 plus minus 3x plus 3x divided by 3 is 0. And then my y's, so 6y minus 3y is 0, so it's going to be 0, 0. So centre of mass is along that PQ line. And now we want to work out the area and centre of mass of triangle APQ. So triangle APQ. Area, well, the distance across there from P to Q is 4x, half times 4x, the height is 6y, so that is 12xy. And the centre of mass is, so the x terms is 2x minus 2x plus 2x plus 0 is 0, divided by 3 is just 0, and then the y's is 0 plus 6y, so that's 6y divided by 3 is 2y. Okay, so it's up here somewhere. So we've got now our area of ABC, centre of mass of ABC. We've got area of APQ and centre of mass APQ. And then all that's left to do is find the area and centre of mass of PQCB. which I can do from what I've given. So triangle ABC is going to be equal to triangle APQ and trapezium PQBC. Okay, now I'll just take this to this side, take it away to find out what the trapezium PQBC is. So this is minus triangle APQ equals that one there. So it is the area 27xy times by 0, 0 minus the area of 12xy times by 0, 2y. Now this area is just going to be the difference between the two areas. So it'll be 15xy and we'll call this AB as we haven't found it yet. Okay, so the total area is 27xy. If we know that this is 12xy, then this has to be 15xy because we've got 27xy as the total area there. And when I look at the centres of mass, the centre of mass of the whole shape has got to be the average of the centre of mass of the two separate shapes added together. Okay, so effectively cancelling the xy's and dividing by 3 as well, we get 900 minus 402y equals 5ab. Okay, so A equals 0, there's no doubt there, and then 5B equals minus 8y. So B is minus 8y over 5. Now, for the shape F, which is this shape, this PQBC, its centre of mass has stayed in the same place. Okay, so this is still now my x-axis goes, so I'll just put my x and y axes on there. So they're still at the same coordinates, but the centre of mass of PQA or APQ has now changed positions. Okay, it was at 0, 2y, now it's folded over, so it's still 0 and it's now minus 2y. So for shape F, PQBC still has an area of 15xy and a centre of mass of 0 minus 8y over 5, and triangle APQ still has an area of 12xy, but now it has a centre of mass of 0 minus 2y instead of 0 plus 2y. So now we've got the whole shape 27xy, and the coordinates of that would be, I'll just call it capital X, capital Y, and that's equal to 15xy, 0 minus 8y over 5 plus 12xy and 0 minus 2y. Okay, so again I can get rid of the xy's and divide by 3. So I've got 9xy is equal to 5. 0 minus 8y over 5 plus 4, 0 minus 2y. So x equals 0. And then we've got 9y equals minus 8y minus 8y. So capital Y equals just minus 16y over 9. Okay, so that is, as a coordinate. Therefore, the distance from PQ is 16y over 9. Okay, because we're just dealing with direction here as in down from here, whereas this is the distance is just the positive value. Okay, so that's part A done. And there's definitely lots of ways of doing this. Okay, yeah, let me know in the comments if you did it a different way and how you did it. If you could see a way I could do this a little bit quicker or easier, then I'm all ears. Okay, so part B, now it's hanging from P, so PQ must be in this direction. Okay, I won't bother drawing the rest of the shape in. Okay, you know that this triangle here and there is so on. Okay, but the downward vertical, this is going to give me my value of alpha. Now, the center of mass was at coordinate 0, which is exactly halfway between PQ. Now we've already said PQ is 4x, so P to this distance here would be 2x, and then this distance is 16y over 9. Okay, so I got this distance and this distance. So tan alpha equals opposite 16y over 9 over adjacent 2x, and it also gives me that tan alpha is 64 over 81. So taking this one, it is 16y over 18x equals 64 over 81. So x is equal to 16y over 18 times 81 over 64. So cancelling these two, that's going to give me 8 and 9. 9 cancels with that, give me 9. 8 cancels with that, give me 8. So x is 9 over 8y. Of course, you could just put that in your calculator. Okay, and that's part B. Part B, very, very straightforward there. But again, let me know about how you did part A. So we've got a particle of mass 3m and a particle of mass 5m. So that's 3m and 5m. That's P and that's Q. And moving towards each other along the same straight line on a smooth horizontal surface. So they're moving towards each other, and the particles collide directly. So immediately before, this is U and this is KU. Immediately after is 2v and v. Okay, so immediately after is 2v and v. The direction of motion of each particle is reversed, sorry, so that is 2v in that direction and v. In the collision, P receives an impulse of magnitude 15 mv. Show that u equals 3v. Okay, so impulse, change in momentum. Now it receives an impulse of 15 mv. Now for this I'll take left as positive. So that's going to be equal to 3m times 2v minus 3m times minus u. So that's 15 mv equals 6 mv plus 3 mu, or 9 mv equals 3 mu. Cancel the m's, divide by 3, we get 3v equals u, or u equals 3v. So that was part A. Part B. Okay, the impulse here. So impulse equals mv. So it'd be the same impulse, 15 mv, and that'll equal 5 mv minus 5 m ku, and the ku would be minus, it's the opposite direction to v. So I've got 5 mv now. If I wanted to take it as to the right, to the left being positive, for this one I'm taking it to the right as positive, but if I wanted to take it to the left as positive, the impulse to the right would have been a minus 15. So, you know, I would have had minus 15 mv equals, and then it's a minus v. Do you know what I mean? Well, let me explain. So if I was still taking to the left as positive, I've had 15 mv as the impulse, 5m times a negative mv minus 5m ku, and done that. So I'd have minus 15 mv equals minus 5 mv minus, and k is 3v, sorry, not k, u is 3v, so it's minus 15 mkv. Okay, so that's what I'd be looking at here. So minus 10 mv equals minus 15 mkv. Cancel the m's and the v's. 15k equals 10, k equals 10 over 15, or 2 over 3. But alternatively, instead of dealing with all those negatives, you can then just jump to, you know, positive to the right, and then you have a positive impulse. So, you know, if I take to the right as being positive, then I've got 15 mv equals 5 mv minus 5 mku, and u would be negative there, the ku. So 5 mv plus 5 mku, u is 3v, so 5 mv, wait there, we can just take that to the other side anyway. So 10 mv equals 15 mkv, cancel the m's and the v's, and we've got 10 equals 15k, k equals 2 over 3. Okay, so you can either keep the same direction as the first one, or you can change the direction for the second part of the question, as long as you're consistent within the question. Now for part C, we're looking at finding E, and E is the speed of separation over the speed of approach. So the speed of separation is, they're going in different directions, so it's 2v plus v, and then the speed of approach, they're going in opposite directions towards each other, so we're going to add those, so it's u plus ku, so 2/3 u, and of course we know that u is 3v, so that's 3v over 3v plus 2/3 3v, so it's going to be 3v over 5v. The v's will cancel, so E is equal to 3 over 5. Okay, so the loss of energy due to the impact is lambda, so that's equal to half m times u squared plus a half 5m times 2v squared, that's u squared, minus a half 3m times 2v squared plus a half 5m times v squared. So that is 27 over 2v squared plus 2 squared is 4 times 5 is 20, half 10v squared minus 2v squared is 4 times 3 is 12, divided by 2 is 6v squared, and then we've just got plus 5 over 2v squared there, and that totals 15v squared. Sorry, 15 mv squared. And this lambda, as you can see here, is lambda mv. So that's lambda mv, so lambda equals 15. Okay, so we got a uniform beam AB of mass 15 kilograms. So 15 G weight going down there. Rests with A on a rough horizontal ground, and then B rests against a rough vertical wall. Coefficient of friction between the wheel and wall is 0.2, and that one's mu. Right, is that limiting equilibrium? So that's my normal reaction at A. And since if this falls, this will fall down and this will fall to the left. So this has a friction acting to the right here at A. And then similarly up here we've got friction acting at B, and the normal reaction there are at B. And the friction between the beam and the wall is 0.2, so this FB is 0.2 RB, and this friction at the ground, we don't know that, so it's just mu RA. And we need to find the magnitude of the normal reaction between the beam and the wall. The beam and the wall. So we want RB. So take a moment about A. So we'll be able to get rid of that. So first the ones going this way. So this 15G, this just so 15G will split up into this direction and this direction. So this is the 75. So it's 15G cos 75, and this is 15G sine 75. Okay, so that is 15G cos 75. Now it's a distance of 3 away from A, so it's 3 times that. And that is the one going in this direction, so a clockwise direction. Now both these are going to end up going in an anti-clockwise direction. So first we'll deal with the RB. So RB is going to go in this direction and down in this direction. Okay, so this angle here is 75 because of the Z angle. So this is RB cos 75, RB sine 75. And then just changing my color up again for FB. FB is going to split up into this direction and this direction. So it's going to be out in this direction and the same direction as that RB sine 75. Now that's 75, that's 15, 15, 75, 15, 75, 15. So this is my 75 there. So that's going to be FB cos 75 and FB sine 75. So we've done going clockwise. Now going anti-clockwise, so in green is going to be RB sine 75, RB sine 75, and that is 6 away from A, so times by 6, plus, and then in purple is FB cos 75, FB cos 75, and again that is times by 6 because it's 6 away. So we've got 45g cos 75 equals 6rb sine 75 plus. Now FB, we've written it up here, is 0.2 RB. So it's going to be 1.2 RB cos 75. Now, in my calculator, this bit on the right is 114.14. Now I'm going to store it as A in my calculator to use the full value for later. And then on the right I've got 6 times sine 75 plus 1.2 times sine, no, times cos 75, and that is 6.106 RB, and I store that as B in my calculator. So now RB is going to be A divided by B. So it's going to be 18.7 newtons. Doesn't say what to round to. So 3 significant figures there, 1 decimal place, however you want to do it. Okay, so that's all part A. Now, part B. Okay, so part B. Let's resolve horizontally first. So that is going to the right. I'll put on the right. So FA. It's the only force going to the right. And going to the left is RB. So FA equals RB, so it equals 18.7 newtons. Resolve vertically. So going down is 15g, and then going up is RA and FB. Now, let's do that. FB is 0.2 RB. Okay, so take RB times by 0.2 and we get FB, so 3.74, and that's 15g. So we can find out what RA is here. So 15 times 9.8 minus answer 143.26, so 143.3, and I'll store that in my calculator as C in case I need it later. Now FA equals mu RA, and we know that FA is 18.7 mu and RA is 143.3. So the 18.7 that we had earlier, divide by what I stored as C, mu equals 0.130478, so on. So U equals 0.130 to 3 significant figures. And that's question 5 done. I'm sure there might have been other ways you could have done part B there, but I think that was the easiest way. Let me know if you did it any differently. So for this one, we've got a van of 900 kilograms, going on a straight horizontal road. The resistance to motion is a constant and it's at 600 newtons. And then the engine force is 24 kilowatts. At the instant when the speed of the van is v, the acceleration is 2 meters per second. So a equals 2 meters per second when v equals capital V, or u equals capital V. And the velocity is v. Find the value of v. So first things first, force F equals ma, and power equals Fv. So the power is 24 kilowatts, force and the speed is v. So F equals 24,000 over v, and F, this is F minus 600, because that's the, the force going this way. This is really F equals 900 times 2. So that is putting these two together. It's 24,000 over V minus 600 equals 1800. 24,000 equals 2,400 V. V equals 10 meters per second. Okay, so part B. That's theta there, and sine theta equals 1/14. Now I'm going to model this as both the same as one kind of particle. So 900 and 700 is 1600 G, and the resistance force is 600 and 550, so that is a resistance of 1150. Now the engine is still making 24 kilowatts of power, and the speed is 8 meters per second, and we've got to find out what A is at that point, and then that's going to be my F going up the hill. So F minus 1150 equals 1600 A, and FV equals the power, so 8F equals 24,000, F equals 3,000. Now sorry, I'm going to start this bit again. So F equals MA, because this 1600 G, so that's theta there, so this is 1600 G sine theta. So that's the difference there. So we've got F is 3,000 minus 1600 G sine theta minus 1150 equals 1600 A. So that's 3,000 minus 1600 G times 1 over 14 minus 1150 equals 1600A. Now 3000 minus 1600G times 1 over 14 minus 1150 is 730. Divided by 1600. So A is 73 over 160, which is 0.45625 or 0.456 meters per second squared. Now part C, we've got the trailer and it's now moving on its own because of the snap. It was moving at U equals 9 meters per second, V equals 0. It's going to eventually come to rest, and we've got to use the work energy principle to find the value of D, the distance travelled. Now this should still have a force of 550 newtons, and when I split this up, this is still theta, so it's going to be 700G sine theta going in that direction, and 700G cos theta in that direction. So F obviously doesn't exist, so F equals MA. So this is minus 550 minus 700G sine theta equals 700A. 700G sine theta is 1/14th. So 700 times 9.8 divided by 14 is 490. So 550 minus 490 equals 700A. So that's minus 1040. So this is minus 52 over 35, or minus 1.49 meters per second squared. So that's the rate it's slowing down. And then V equals, or V squared equals U squared plus 2AS would give us the answer, wouldn't it? But actually I'm doing it this way, and it does say use the work energy principle. So actually scrap this, because we need to do it a different way. So work done equals force times distance. So I wrote that really small there. So the work done would be the change in kinetic energy. So half M, I'll write it out in letters first. So half mv squared minus a half mu squared equals force times d, because d is our distance. I'll deal with the force in a moment. So half times 700 times 0 squared minus a half times 700 times 9 squared. And the force, now there's obviously no force going up anymore, so it's just going down. So minus 550 minus 700G sine theta times by d. So that gives me minus 28350 on the left. And we've already worked this out once with the sine theta being 1 over 14. And this is minus 1040d. So 1040d equals 28350. So divide, so 28350 divided by 1040 equals 27.3 meters. So it's 2835 over 104, which is 27.26 meters, or 27.3 to 3 significant figures. Okay, so that was how they wanted you to answer this, because it's the work energy principle. So how I first started doing it would have got you the right answer, but not would have answered it in the way that they required. So more than likely would have scored you a 0. Okay, let's move on. Final question. So for this one, the kinetic energy it has at this point, where it's immediately before it hits the ground, is going to be equal to the kinetic energy it had at the start plus the potential energy it gains through dropping. Now first I'm going to find out what this speed is. So 3 squared plus 2 squared square root. So that's root 13 there. So we've got a half mv squared equals a half m times 13. Root 13 squared is 13 plus h is 20, so 20 mg. I can cancel the m's because it appears in every term. So half v squared equals, now half of 13 plus 20g, so 20 times 9.8 is 196, so it's 13 over 2 plus 196. 405 over 2 equals half v squared. V squared equals 405. And square root in that is 9 root 5, which is 20.13 significant figures there, meters per second. So at B, where it's obviously going like in this direction, so we're going to measure to the horizontal. Alpha is angle to the horizontal, like so. So that is like this. That's my alpha. And that's my triangle there. Now, when particles and things are thrown off here, there's no forces on this. Well, there is actually air resistance, but you know, we're obviously ignoring that in this question. So this 3i is still going horizontally. So 3i, or 3. So that's the horizontal speed. And then this diagonal speed is 20.1. So alpha is, cos alpha is opposite over hypotenuse. So 3 over that, shift cos. So the angle is 81.4 or 43. There's the 3 significant figures. I'll do this, so 81.4. Okay, so that's just finding the angle, and the horizontal speed is still going to stay, it's going to remain constant. It's not affected by gravity, and there's no air resistance in this question. Okay, part C, find the time taken for the ball to travel from A to B. So we've got U, we know is root 13, which is 3.6 meters per second. We got S is 20. If we go in down, if I'm taking this as the starting point, minus 20. We got gravity 9.8. We've got T, which we want to find. We know V is 20.1, but obviously we've worked that out. A is gravity, yeah. No, so hang on. So U and OV are not speeds, are they? So looking at the, resolving this like vertically, the vertical speed here is 2I. We don't know what the vertical V is. We could work it out, but the component force. But why bother? So 2I, so that's just going to be 2 in the I direction. In the J direction. So from here. So S equals UT plus half AT squared. And if this is going to be negative, minus G. So if the 2's positive going up, then G going down is minus G. So minus 20, distance down, is 2T minus a half GT squared, which is 4.9T squared minus 2T minus 20 equals 0. So use the formula here, and you get T equals 2.2 seconds, or T equals minus 1.83. Obviously the minus time is not possible, so 2.2 seconds there is the correct time. Okay, or 2.23 to 3 significant figures. Okay, so that's part C done. At the instant when the direction of motion of the bird is perpendicular to 3I plus 2J, the ball is h meters above the ground, find h. So part D, at some point here, we've got this 3I plus 2J, and this one then is perpendicular to it, so at 90 degrees. Now, it's still going to be 3I because that's going to be unchanged, isn't it? There's no forces acting on that. So plus, and let's call this a lambda J. Now, when two vectors perpendicular multiplying together equals 0. So 3I plus 2J multiplied by 3I plus lambda J equals 0. So in this case, it's 3I times 3I, so it's 9 plus 2 lambda equals 0. So 2 lambda equals 9, lambda equals 9 over 2. So the velocity, is going at 3i. Hang on, so that's a minus 9 over 2j. That's the velocity when the height there is h. So u equals minus 9 over 2 for that vertical, height. Now, hang on. I know what we'll do. We'll go from point A. So u equals 2, v equals minus 9 over 2. S we want to find, and A equals the gravity, isn't it? So minus g. So v u a s, so v squared equals u squared plus 2as. Now before we're going to start, I'm going to take on this part downward as positive, because this distance here is s. So if I didn't take downward as positive, that s would also be a negative value. Okay, so I could substitute in a negative one there, but let's change these to, so that's minus 2 plus that, and that one's plus. So 9 over 2 squared minus 2 squared plus 2 times g times s. So 81 over 4 equals 4 plus 2gs. 81 over 4 minus 4 is 65 over 4. So S equals, so divide that by 2, divide by 9.8. S equals 0.829 to 3 significant figures there. And then H is 20 minus S. So it's 20 minus 0.829. So 20 minus that is 19.17 or 19.2 meters to 3 significant figures there. Okay, so that's the M2 paper done. Hopefully you found some aspects of this video useful. If you did, please hit that like button, subscribe if you haven't done so already, and don't forget to let me know in the comments if you did any of these questions in a different way. Maybe you can show me an easier way of doing some of these. This is obviously how I've done the questions, but I'm sure there are some easier ways that I haven't thought about in this video.